All right, I want to quickly show you some of the manual testing features available. First, let's click on the manual test icon. When I do that, we have 4 different types of manual testing to choose from. If we want to do it the old school way using the wheel, I can start by selecting the momentary output. For example, let's say I want to set it at 700 amps. To do this, I click on a location on the wheel that I think will give 700 amps output. Then I hit play. I got a meter range error because the test set put out over the range I had selected. I'll need to adjust the range. Now, I can move to a higher part of the wheel because I was below 700 amps. Let's try again. I'll adjust the setting and hit play again, and the test set will send out another pulse. That pulse was 600 amps. If I want 700 amps, I can simply click the wheel again and increase the output. Alternatively, I can use the bump buttons to increase the current incrementally until I reach my desired value. If I'm way off, I might want to move the wheel rather than bumping the current. You can also change the percentage setting for larger increments. Once I'm happy with the current being close enough to the 700 amps, I'm ready to run my tests. I simply switch from momentary to continuous mode. Now, when I hit play, the system will run the test until the breaker trips. I can adjust the current up or down while the test is running. So, if I'm a little high on current, I can bring it down or I can increase it if needed. Let the current run until the breaker trips. That's one way of performing manual testing. The old school method using the wheel and percentage output. Another way to test manually is by requesting a current. Here we have 2 functions, momentary and continuous. Momentary is similar to testing instantaneous breakers. For example, let's test a breaker with a 2900 amp instantaneous trip. Set the current to something lower than the trip value, like 2800 amps. The system will find that current and then stop. Set it at 2800 amps and hit play. The system will find the requested current. Then you can bump the current up incrementally to see where the trip occurs. I'll keep bumping up current until I reach the trip point. Here, the breaker tripped at 2924 amps. Continuous requested current works the same way you can enter 2800 amps. It will find the requested current, pause 2 seconds, then run the requested current until the breaker trips. The test set will automatically adjust the current to keep it within 1% of the requested current during the test. The test set will stop and record the time when the breaker trips. Using the manual mode is a good tool for troubleshooting. Another useful feature to discuss us all the screens provide the minimum input voltage during the prior test. During tests, the input voltage can sag because of the high current demand. For example, in the last test I did, the voltage started at 476 volts, but dropped to 474 volts during the test. If you're using long leads, power the test set with a small service, or testing with a generator, the voltage input can sag. Primary injection test sets are voltage dependent, and if the input voltage drops, the output voltage will also drop, which means less current will be delivered. We've added a visual indicator on all screens to show you the lowest input voltage seen during the last test. It helps you understand how much the input voltage is affecting the test set output. In the last test, the voltage dropped slightly. This is why we recommend using a large breaker, like a 200 amp breaker, to feed the test set. A larger breaker ensures that the cable running back to the main switch room is rated for the current you're testing. If you use a smaller breaker like a 100 amp breaker, the 100 amp breaker will not trip, but a 100 amp service will sag much more than a 225 amp service. Although the test will still run, you might not get the full current capability due to the voltage drop. And that's a quick overview of manual testing and the importance of monitoring voltage during tests. Thanks for watching.